Okay, good morning, everyone. And welcome to the last 3 weeks of classes. Let's say about what we are going to be doing the last 3 weeks. Today, we're basically going to finalize the trigonometric part of the course. And we're going to start talking about what we call conic sections. It means we're going to talk about the circle, the ellipse, the hyperbola, what is their equation. And then at the end, we will do how to solve a system of equations, which is usually fairly easy and the student have no difficulties with it, all right? So please, as usual, if you have any questions, start putting them on chat from the homework. We go through them. Any questions from the homework? All right, so I'm going to ask you a few questions that I've talked about before, but let's make sure that you guys got them. So true or false? Sine of minus t equals sine of t. Is this a true or false statement? True. Please put on chat your answer. False. Now, if false, you give me an example. It's true, you justify. So if false is correct, so you give me an example to convince me it is false. You need to give a specific value of t such that c of minus t equals sine t. And give me a value that's really kind of easy that we can work with. Or who can give me a value that we can work with? What do you mean 2? It means the angle is 2. Give me something we know what's the sine of. Something easy. Pi over 2. That's a little bit better because we don't have issue with pi over 2. So what is the sine of pi over 2? So we're going to go back to our unit circle. This is pi over 2 from here to here. So this is pi over 2 minus pi over 2. It means we go in the opposite direction. So the sine of t, of course, it's positive. It's equal to 1. The sine of minus t, it means if you evaluate this minus pi over 2, it's obviously minus 1. Okay, so that's really how we say that it's false. I mean, because if this is sine of t is the y coordinate, if this is the sine of t, the minus t is going to be set right here, so it's negative 1. All right? What's the correct version? True or false? Okay, so is this true? So that's my first question, true or false? Now, this one, true or false? This is absolutely true. Who can give me a justification for that? So why it is true? And I want you to think on the unit circle. Why is this true? You can unmute yourself and talk. If true, there should be a reason why it is true. Anybody would like to explain? Okay, so let us think about it. Okay. We use the unit circle to basically understand. Suppose I have an angle t, whatever this angle is. This is t. The sine is the y coordinate. If I take the point P, the sine of t is the y coordinate of P. No. I don't know. I don't understand this, Jacob. All right. Minus t is this angle right here. So the sine of minus t, if this I call the point Q, I call this point Q, the sine of minus t is the y coordinate of q. Okay, so the sine of t is the y coordinate of the point P. That's really what's happening mathematically. And the sine of minus t is, by definition, the y coordinate of the point Q. So this is minus t, so that's the y coordinates. This one is here and this one is here. So now from the symmetry of the unit circle, or actually using symmetry, P and Q are symmetric with respect to the x-axis. So if you look at those points are symmetric, it means, from using the symmetry here, it means the y coordinate of P is minus the y coordinate of Q, or actually the other way. Okay. So the y coordinate of Q is minus the y coordinate of P. So they are equal, but they are opposite sign. So that means that tells me that minus the sine of T is the sine of minus T. That's really the idea. So it's really, we have to think about that on the unit circle. This is T. The sine is this value. This is minus T. The sine is that value. Those are equal to each other, but opposite. So the one is negative the sine of the other. That's why this is absolutely correct. All right, so I finalize with one more true and false. Is the tangent of minus t true or false? Okay, so I will write it again on another piece of paper and ask you the question. Okay, is this true or false? Think about it a little bit. You can think of tangent as sine over cosine. Anybody has any idea? Okay, somebody tell me think it's false. Anybody else? Anybody? Okay. Let's think about it as sine over cosine. It's true. Okay, let us think about it. We're going to think about it in two ways. First, in terms of sine and cosine. What's the tangent of minus t? Whatever the angle here, it's the sine of it over the cosine of it. Okay, so it's the sine of minus t over the cosine of minus t. But what do we know about the sine of minus t? So now if we go back to the unit circle, this is my angle t. Minus t is, you go right here. That's the minus t. Okay, right. So what's the sine of minus t? So that's the sine of t. That's the sine of minus t. That's the minus of the sine of t. So the sine of minus t is whatever the sine of t is, but it's the negative one. What about the cosine of minus t? Is it equal to cosine of t? Back to you. Is cosine of minus t equal to cosine of t? Yes or not? Yes, the cosine of minus t, that's the cosine of t, is the x-coordinate. Cosine of minus t is the x-coordinate. That's the same thing as the cosine of t. So this will give me minus the sine over the cosine, which is minus tangent of t. So they are absolutely a true statement. They are absolutely a true statement. Another way you can think about it, if you take or, if this is t and this is x and y, what's going to be the coordinate of this point? This x and y, and this is minus t, this is the same x, but the y is opposite. So the tangent of minus t, you can think about it, is nothing more than minus y over x. And the tangent of t is the y over the x. So if you put two together, we know that the difference between them is a minus sign. Okay. So if this is true, absolutely true, and this is mainly because the cosine of minus t equal the minus of sine t. So if you go back to the unit circle, you can actually convince yourself a lot of those properties, but you have to go back to the definition of the unit circle to be able to do that. All right, now back to you. Do you guys have any questions? I'm always the one asking you questions. Did you do the homework? Okay. All right, so I will go through some problems just from the top of my head, and then I will move on to circles. You know, every time I have 3 other classes beside this class. Every time I go to the other class, they actually ask a lot of questions. That's the only class when students don't ask, which is actually, I don't understand why. I mean, you guys should have to do the homework. You should struggle and you should ask questions, but you don't. Okay. So I will see what Jaden has to say. In the worksheet in section 3, can you work out problem D? Sure. Okay. So I gave you this in the worksheet, and the question is verify the following identity. So we will do that very slowly. So worksheet number 3, part D. And we have to work out the following identity. So I'm asking you that to convince me that this complicated statement plus 1 plus the cosine of t over sine t is equal to 2 over sine t. Okay, so what does this mean? How do you verify this identity? You start from the piece in the left and you try to manipulate it somehow so you can reach 2 over sine t. So the question is that no matter what t is, you have to show me that the left is equal to the right. So how do we proceed in problems like this? Okay. What do you think will be the right approach? Make the denominator equal to each other. So we're going to find a common denominator, because somehow I have to simplify this expression, common denominator. Okay. So this looks like a little bit complicated as a common denominator, but the only common denominator here is basically the product of 2. So the common denominator here is going to be 1 plus the cosine times the sine. That's my common denominator. So it's the number that's a multiple of this and a multiple of that. It's like when you take a half plus a third, the common denominator is 2 times 3. That's the same idea. So let's do that. To have this common denominator, 1 plus cosine has to be multiplied by the sine. So I'm going to multiply this by the sine, and down here by the sine. Plus, I will do verbatim here. 1 plus cosine. If this is the common denominator, means I need to multiply this by 1 plus cosine. And my goal to reach 2 over it. All right, so let's do that. The goal of finding a common denominator is to be able to combine the numerators. It means now I have a huge denominator, which is 1 times the sine. And then the numerator is sine times sine. It's the sine square of t plus 1 plus cosine times 1 plus cosine. So I'm going to multiply those by each other. So we distribute. 1 plus 1 times 1 is 1 plus cosine plus cosine. Cosine times cosine will give me cosine square. So this should be cosine square. Okay. And now we're going to a little bit kind of put things together and see what I get. So finally I will have, and I need to that's my goal. 2 over sine of t is my goal. So I keep always the goal in front of me. So I'm going to have sine square of t plus 1 plus cosine t plus cosine t is to 2 cosine t plus the cosine square of t over 1 plus cosine times the sine. And my goal at the end is this. That's really my goal. Okay, who can help me to reach my goal? Okay, somebody is telling me that use the fact that if I combine this and this, I get 1. We're gonna do that. So this is, I'm gonna write it as. So my goal is here. So I'm gonna put it in front of me. So I will rewrite as, I'm gonna kind of combine those two. I'm just, I'm rewriting. I'm not really doing anything deeper than that. Over 1 plus cosine t times the sine of t. So I rearranged the terms so I can combine that. So this will give me sine plus cosine, that's the famous identity. Give me the 1 plus the 1 plus the 2 cosine t divided by that. Again, that's my goal. Who can help me to my goal? Who can see a little bit into it to help me reach my goal of 2 over sine? Any ideas?
Well, you have 2 cos t in the numerator, and you also have cos t in the denominator. So
Cosine. You should use cosine. Go ahead.
Can't you distribute a cosine out? Because you have one in the numerator and the denominator?
So what do you want me to do? I cannot simplify. I cannot get rid of that, right? To be able to... What? Go ahead, I'm listening.
First, since you have 1 plus cosine t in the denominator, can't you make 1 into, what is it? Isn't there an identity? 1 equals sine 2t. Wait. You'd have to change 1 into a, what is it? Sine plus.
No, the identity involves cosine square. I don't have square. I'm gonna go one more step with you. One more step. That's why I want you to guys struggle with those problems a little bit on your own. 1 plus 1 is 2. Big deal. Plus 2 cosine t over 1 plus cosine t times the sine of t. Okay, I didn't do much. I just add 1 plus 1 is 2. That's all I did. All right. Can anybody see anything now? Just stare at it. Stare a little bit at it. See what you can do. No, distributing the denominator get me nowhere, because if something is factored, we don't distribute because we lose something. Anybody? Would you reduce the cosine of t? What do you mean by that?
You could simplify the 2 plus 2 cosine t
How?
with the 1 cosine t by having it be 2 over 1.
But what do you want me to do? I think you are on the right track. So make it a little bit concrete.
You pretty much simplify it in the sense that it's equal to each other. It's just that one is 2 times and the other one is just 1.
Okay. I think what you're saying, but I'm afraid I'm putting sometimes words in your mouth, but let me see what the way I'm seeing it. So I will pick this up here. So I know that that's my goal. So I'm going to factor out the 2. Can I do that in the numerator? Is this correct? Ask the question. Can I factor out the 2? From here to here, am I doing the right thing? 2 plus 2 cosine. I just put the 2. I will have 2 times 1 plus 2 cosine. So I just really factored out the 2, which is a little bit what your classmate is trying to tell me. Now I can start the simplification because I have 2 times something over 1 plus cosine times. So this is a common factor in the numerator and denominator. Now I can simplify, and this would leave me with 2 over sine of t, which is my goal. Okay, so to make sense out of your classmate is telling us, I factored out the 2, which leave me 1 plus cosine. Now it's correct, 1 plus cosine. That's a common factor. That's what I can simplify, which leave me with 2 over sine of t. And off the problem.
Okay.
It's making sense?
Yeah, you factored out 2 in the
I
numerator.
factored out 2. I cannot simplify. I can't. If I have 2 cosine t and 2 plus, there is no way I can get rid of the cosine here. I cannot get rid of it. The only time I can get rid is that I have the same factor in the numerator denominator. That's what I can simplify. And that's the only case I can simplify.
Okay.
So this is a nice problem because the goal of that is really to work on your algebra a little bit. Okay. Any other questions? Any other question from the homework I assigned in the book? All right. So number 18 was very good. Another problem I would like to look at. Okay. From section 9.3, I would like to look at one problem. I don't know how many on the quiz. You will see it soon. So in section 9.3, I'm going to look at one problem because I think it's good for 2 reasons. So I'm going to look at number 18. Okay. And number 18 is the following. Last time I mentioned all the addition formula. So last time we mentioned the following. So I started with the following question. Is the cosine of a plus b true or false? Back to you. True or false? What do you say? Can I split the cosine? Okay. Last time we did that with the sine. Now I'm going to go back to the cosine. So if I have cosine a plus b, so the question is true or false? can I split if I have a sum? Any idea? Okay, it's false. We cannot split. So if I have the cosine of the sum, I cannot split into cosine A plus cosine B. Who can think of an example? It means give me an angle A, whatever you can think of, and give me an angle B, so that this property fails. 20 and 20. Okay, I don't have any issue with that. I take A to be 20 degrees and B to be 20 degrees. All right, I'm gonna do exactly what your classmate gave me. So A plus B will become 40. All right, so I'm gonna compute, evaluate that. It means the cosine of 40. And since I don't know what the cosine of 40, I'm going to pick up my calculator and see what we get. So the angle are in degree mode. So I have to make sure I am in the right mode. I'm already in degree mode. So that's the cosine of 40. Cosine of 40. This is 0.76. Okay. Now I'm going to split and evaluate. Cosine A plus cosine B is the cosine of 20 plus the cosine of 20. Okay, and I will evaluate this. So the cosine of 20 is 0.93. 9, and this is the same thing. So we're gonna, if you add them, we get 1.879. So absolutely different from each other. Okay, actually, when we took cosine A plus cosine B, we can get a number bigger than 1. However, the cosine by itself has to be less than 1. So the bottom line is that we cannot split. If we have a sum, we cannot split. The same thing last time we said, if to have the cosine of 2 theta, this is not, we cannot pull the cosine. So we cannot pull the 2. So those are operations are not false. So in number 18, we want to do the following. So that's why we have the sum formula. And for the cosine, we have the following form. We have the cosine of A plus B, whatever the angle is. And there is a nice trigonometric formula that tells me what's happened. So tell me that it's the cosine of the first times cosine of B minus. And I told you that you don't have to memorize those. Those are formulas that will be given to you. But you should be aware of them. You should be aware that we cannot split the cosine. And the same thing, I have cosine A minus B is going to be basically the same. Okay. It's going to be cosine A, cosine B plus the sine of A, sine of B. So we cannot split, but that's the relationship. All right. So number 18 is the following. Number 18, part A. They want us to use this following formula to convince you that if I take the cosine of t minus pi over 2, it's the same as the sine of t. And then we're going to see graphically what situation. So if you take the cosine of t minus pi over 2, they want us to use this formula here to convince us it's exactly the same as sine t. Means if I plug in any value of t here, any value of t here, those are equal. So let us do that verbatim. So using, we get, so that's the formula I'm going to use. Okay. This is equal to what? This is playing the role of A, and this is playing the role of B. So this is cosine of A, cosine of t, times the cosine of B, pi over 2, plus the sine of A is that. The sine of B is sine of pi over 2. So this is equal to what? Cosine of t times the cosine of pi over 2. Pi over 2, we take the x coordinate, which is a 0, plus the sine of t times the sine of pi over 2 is 1. So it means that the cosine of t minus pi over 2 is basically equal to the sine of t. So if you take the sine, the cosine, and basically you shift it a little bit, you get exactly the sine of t. Right? So let me show you this graphically. It means graphically what's really going on. What do I mean graphically? Graphically, I mean the following. If I sketch the graph of sine of t, which is basically, this is the graph. And then I sketch the graph of t minus pi over 2, I get the exact same picture. I mean, those two are exactly the same graphically. So let me show you on, share the screen with you a little bit and show you that. So I'm going to share the screen. And I'm going to go to decimals here. And I want to show. So this is the sine of x. I cannot write t, that's the sine. So it goes, start at 0, go up, down, down. Okay. Now I'm going to sketch the cosine of x minus pi over 2. And I want you to tell me what's really going on. Do you see anything changes? That's the cosine of x. So I'm going to actually make this color red. Okay. So if I sketch, that's cosine x minus pi over 2. That's the red graph. I sketched the graph of sine, the green one. Nothing changed. I mean, the two graphs are exactly the same. It means whether I plug in. So as you realize, you guys don't see anything. However, when I sketch the graph of cosine x, things are changing. So the orange is the graph of cosine. The graph of sine and cosine x minus 2 is basically the graph of cosine if you shift it a little bit by pi over 2. So take the yellow, the orange one, which is the graph of cosine. Just take it and shift it with your hand horizontally by pi over 2. You get the graph of sine, and you get the graph of cosine x minus pi over 2. So sine x and sine x minus pi over 2 are exactly the same thing, exactly the same graph. So that's how we interpret these identities. Any questions before I move on? Today we're going to start section chapter 14, which is that's what in your curriculum, and we're going to do section 14.2. Okay. And in this section we're going to talk about circles. Okay. What's the equation of a circle and how we work with circle. First, distance between 2 points. So this is going to take us a little bit, away from trigonometric function, and we're going to go back to Cartesian plane and equation of circles in the plane. But before that, we need the formula for the distance between 2 points in a plane. What do I mean by that? Suppose I have 2 points. One point A, one point B. And A has for coordinate, let us see x1, y1, and B, x2, y2. So these are the points. The question is, what's the distance between them? What's the formula that will give me the distance between those 2 points? So let me call D the distance between them. How can I find it? So it basically, if I know the coordinate of A, the coordinate of B, and I measure the distance, what's going to be the formula for the distance? This is x1, this is x2, and this is y1 and y2. Okay, and those are the 2 points, x1, y1, and x2, y2. Okay, and my goal is, what's the distance between them? how far they are. All right, it's not the slope, it's the distance. Do not confuse the ideas. Okay, how are we gonna compute the distance? First, I wanna evaluate from here to here. From here to here, that's the change in x, is x2 minus x1. That's how far we are from here to here. What's the distance between the vertical distance between A and B? So the horizontal distance between them, x2 minus x1. The vertical distance is y2 minus y1. I want D. How can I get D? Use the picture and the famous Pythagorean theorem to find a formula for the distance. So what does Pythagorean theorem? I'm going to think about what's happening in this triangle. What is Pythagorean tells me D squared equal? If you take the distance squared, it's going to be equal to. From here to here squared, it means x2 minus x1 squared plus the vertical distance squared, y2 minus y1 squared. So that's the distance between 2 points. So if I have A, I have B, that's the distance. So in other words, D is the square root of this, but I need both of them. That's a formula which is extremely useful for any of you who want to get into anything related to the sciences. Okay, so that's the distance between 2 points. So for example, very simple example. Okay. Find the distance between the following 2 points. Okay, how far they are from each other. So I'm going to take the point 1, 4, and the point which is B 2, 6, for example. Okay, so I have 2 points in the plane. The point A, 1, 4, means this is 1 and this is 4, and the point B, which is 2, 6, somewhere here. Find the distance between them. It means I need to find how much do we have from here to here. So if I have a ruler and I measure this, what's the distance between them? So we're going to use the formula verbatim in here. So the distance square, and if you ever forget the formula, it's actually, that's really what I'm computing. I'm using Pythagorean here. So the distance square is going to be equal to, this is x1, this is x2, I meant y1, this is x2, and this is y2. Do not confuse with the slope. I'm finding the distance. So what's d squared? It's y1 minus y2 squared plus x1 minus x2 squared. Or actually y2 minus y1, x2 minus x1. So I see the d squared is equal to what? Plus y2 is 6 minus y1, it's 4 squared, plus x2, which is 2 minus 1 squared. So basically on the picture, this is the 6 minus 4, because this is 4 and this is 6. So 6 minus 4, that's the 2 in here, and 2 minus 1, that's the 1 in here. I'm using really Pythagorean. So this will give me 6 minus 4, that's going to give me a 2 squared plus 1, which is 5. So d squared is 5. It means that the actual distance is the square root of 5. So that's how we really apply the formula to find the distance between 2 points. All right, so the idea is that what does this have to do with the circle? I mean, why I am talking about the distance formula, which is very important, but what does it have to do with the circle? Right. So what's a circle? What is a circle? Geometrically, what is really a circle? The circle is the following. It's characterized by 2 things, by the center and by the radius, r. That's what characterizes a circle. You give me the center, you give me a number r, and the circle is all the points who are at the distance r from the center. So this is really what the circle. Now I know that all of you know that, but this is an r. From here to here, we have an r. From here to here, we have an r. So what is a circle? Circle is characterized the following. We fix a center, we call it C, and a number r, and the circle is all the points in the plane that's at the distance. So all the points that's at the distance to C is R. So there are a lot of points that satisfy this condition. Now, what do you mean by the equation of a circle? Equation of a circle centered at the origin with radius r. What does it mean, equation of a circle? What does it mean? What does the word equation mean? It means the following. If I take a circle and centered at the origin, so that's the origin, and the radius is r, that's my circle. So that's my r. What does it mean, equation of a circle? What does it mean? It means the following. If I take any point on the circle, P, this point has two coordinates, x and y. Equation, it means what's the relationship that exists between x and y. So finding the equation, it means if you take any point on the circle, what's the relationship that exists between its x and y coordinate? What's the equation that relate the x and the y? Anybody has any idea? So it's like when you have a line, if you have a line, because remember, if I tell you y equal to x plus 1 is the equation of the line, means what I am doing is I'm finding the relationship between any 2 points on the line. So if I take a point between the coordinate of a point on the line, if I take a point on the line, the equation tells me, okay, what's the equation that relate the x and the y? That's what the equation here. So now the question is, what's the equation that relate the x and y if we are on a circle? All right. What characterizes the point on the circle is that the distance from here to here is fixed. No matter what the point is, the distance from the origin to the point P is always equal to R. And this is gonna actually give me the following relationship. If this is xy, it means from here to here I have y, because this is 0, and from here to here I have x. And this is r is fixed. So what's going to be the relationship is the following. By using Pythagorean theorem, the relationship is going to be, if I take x squared plus y squared, this has to be, if the point is on the circle, this has to be r squared. Means if I take the point of the circle here, x squared plus y squared is not going to be equal r squared. So what characterizes the point on the circle is that this relationship. And this is called the equation of the circle. It means this is the equation that relates any 2 points on the circle. So let us write very simple equation. So the question is, write the equation of the circle centered at the origin with radius 2. Means basically I'm asking what's the relationship between any point on the circle with radius 2. All right, based on that. So the formula tells me that the equation is x squared plus y squared equal to the radius square. it means the equation is x squared plus y squared equal to 4. So if I take a circle of radius 4, sorry, of radius 2, let's say 2, I take any point here, x, y, the relationship between x and y is x squared plus y squared has to be equal to 4. So let me ask you the following questions. So is the point 1, 1 on that circle? Means the circle before. Yes or no? Yes, you justify. No, you justify. If I take the point 1, 1, is it on that circle? What can you say? How can we verify this?
You're talking about the circle with a radius of 2, right?
Exactly, on that circle. How can you tell? Because the idea is, what does this equation mean? What does it mean I'm finding the equation of the circle? So I'm talking about that circle. Is 1, 1 on that circle? Means if I draw the point 1, 1, is it going to fall here? That's what I mean. So on the circle means, is it going to be somewhere here? And how do we know? So I'm getting 2 yeses. Why yes? Jaden or Aaron, just unmute and tell me why yes.
Would it be because the radius is 2, and since the point is smaller than 2, it would fit into the circle?
But let us make that clear. On that circle, it means right here, not inside. It means on the boundary, on the circumference. It's me here. That's what I mean on the circle. It means, is it on here?
So then no.
Then no, right. Why?
Because the point is 1, 1. That wouldn't, it's not 2, like the distance wouldn't equal 2.
Okay, so the point 1, 1 is going to be basically here. It means the distance from here to here is not 2. That's what you mean, right?
Yeah.
Okay, now what's another way we can do that? You're absolutely correct. What's another way we can do that? To be on the circle, it means the x and y should satisfy this equation. But that's what characterizes the point on the circle. So I ask myself, if I plug in 1 for x, 1 for y, do I get a 4? And that's would be. So it's 1, 1. So I ask myself, does it satisfy? So 1 squared, and that's I'm computing the distance now. This is equal to 2, which is not 4, so it's not on the circle. So if the point on the circle, let's make very sure what we mean on the circle. It means, is it on the boundary? Is it right there? So the only way we know, we say, okay, does it satisfy the equation of the circle? If I plug in 1 here, 1 here, do I get a 4? And the answer is no. Okay, so now let me take the following point, which is a little bit harder. Is the point square root of 2 on that circle? I am talking about the exact same circle. What can you say? I give you a minute to figure out the answer. So how can we justify, is it on that circle? So the only way we do it is we plug in square root of 2 for x, square root of 2 of x. Ask ourselves, is it on the circle? So let's try it down. I take plug in square root of 2 for x and the square root of 2 for the y. And the question is, do we get a 4? If we get a 4, it means yes, the point is somewhere here. If we don't get 4, it means no. So we evaluate. The square root of 2 squared is a 2 plus 2 the equation is satisfied, it means the point square root of 2 and 2 is on the circle. It means on the boundary, not inside. So graphically, if this is the square root of 2 and this is the point, this is the point right there. That's square root of 2 and square root of 2. So to show that a point is on the circle, we actually make sure that the point satisfies the equation of the circle. All right. You guys can start your quiz, and I'm going to put a worksheet on Brightspace. Work on the worksheet for next time. Okay, get going. Good luck.